And now I'd like to talk about something which is related to, but not quite the same as, the standard deviation, and that is the standard error of the mean. So what this is a concept about is we're thinking about random sampling. So if you take a random sample from a population, how similar can you expect its mean to be to the mean of the population as a whole? So if we measured the heights of 5 students out of the first year, how similar would we expect the mean of those heights to be from that sample taken at random to the mean of the population if we measured all the students' heights? And this is stuff that we're doing about with Dr. Craven, but I just thought I'd talk about it briefly here anyway. So the standard error of the mean, or SEM. So what we're getting at is, does the mean of your sample accurately reflect the mean of the whole population? So I'd just like to illustrate that with a bit of an example. So for instance, let's imagine we've got a population of measurements. So here are the measurements from all the different individuals. So here are 10 individuals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our population mean is 5.5. And then imagine 3 different random samples. So if, let's say we got 2, 6 and 9, so then the sample mean of this one would be 5.6, which is quite similar to the population mean. That's not bad. But now imagine if we had a different sample of 1, 2 and 3, for instance, the smallest ones. So there the sample mean would only be 2. Or if we took the biggest ones, 8, 9 and 10, these guys, then there the sample mean would be 9. So that shows us that the sample mean is not necessarily very close to the population mean. So that's what the standard error of the mean is. So the standard error of the mean gives an indication of how different from the true population mean you might expect sample means to be. Okay, so what factors are going to affect the SEM? So what is going to give us a more trustworthy mean, if you like? A more trustworthy sample mean. So one that's more similar to the true population mean. So the first thing that's going to make that more reliable is low variation in the population. So if they're all very close together, then it doesn't matter so much which ones you pick, which your random sample ends up being, because they're all quite similar to begin with. And how do we measure variation in the population? By the standard deviation. So that's the first thing that needs to go into our standard error of the mean equation. So that's going to be involved. And then also we need to take into account the population size. So if we've got a large population size, and that's also going to be important because we're going to be taking account of as large a possible of a proportion of the whole population as we can. So that's all also going to be taken into account. And in fact, what we do is we divide the standard deviation by the square root of n, and that gives us the standard error of the mean. So it's inversely proportional to the square root of the population, of the sample size, sorry. Oh no, this should say sample size. Forgive me. Sample size, not population size. So let me just demonstrate that quickly. So if we got a standard deviation of 100, let's say, just for argument's sake, if our sample size, is 5, then the standard error of the mean is 100 over the square root of 5, which is 44.7. But if our sample size is 10,000, then the standard error of the mean will be 100 over the square root of 10,000, which is 1. So the standard error of the mean goes down as our sample size increases. And as I said, this is all going to be covered elsewhere in the course, but I just wanted to go through it here just quickly.